Hey everyone, this is MusicTechHelpGuy, and welcome to part 2 of my iZotope Ozone 7 series. In the last video I went over the basics, and in this video I'm going to cover the equalizer module, well most of it at least. There's one part to it that we're going to save for part 3. If you're interested in following along with me, this multi-track session is available for purchase and download. I'll leave a link to it in the video description below. So for this video I'm using Ozone directly on the master stereo out. Note that because I'm going to do tutorials on each of the modules in this order, the order that I master this track may be a little out of order. Normally I'd start with drums, then go to bass, then guitars, then vocals, then final mastering. But here I'm going to demonstrate each plugin in the order that's shown here. There's 3 views in Ozone's EQ: Spectrum View, Detailed Band View, which shows the details for each band, and All Bands, which shows some details for all the bands simultaneously. I'm going to use Detailed Band View. So the EQ in Ozone has 8 different bands, each of which can be one of 5 different filter shapes. They can be a high-pass filter, which means it allows highs but cuts lows, a low-pass filter, which allows lows but cuts highs, a low or high shelf, where you can boost or cut frequencies above or below a certain frequency range, or a bell curve, where you can limit your boost or cut to just one frequency band. When you click on or move one of the bands in the graphic interface, you'll see its detailed information in the bottom view here, including its frequency and gain. The frequency for filters is called cutoff frequency, as opposed to bell curves where it's called the center frequency. Also note that gain is not available for low-pass and high-pass filters, since these just attenuate all signal below or above the cutoff frequency. Also notice that each of the 5 filter shapes has its own set of subtypes, as I'm going to call them, giving you 10 different filter shape options for each node. Let's start with the bell curve. The bell curve has 3 options: peak, proportional Q, and band shelf. Each has their own tone and shape. You can adjust the bandwidth or Q of the bell curve by using this line with the 2 nodes on it in the interface, or by adjusting the Q slider in the detailed view. Peak is a typical bell curve. Proportional Q can get a little narrower and notch out frequencies better, and band shelf is essentially a shelf that doesn't stay boosted or attenuated. This one is good when you want to boost up a specific frequency range in a leveling way. Let's try all 3 of these to boost the high end. Note that you can bypass an individual module by clicking here. So there wasn't really a drastic change between the 3 of them, and really not that drastic of a change from the original either. Note that when you boost something all the way up in the interface, it seems to only go up to 5.4 dB. However, if you adjust this from the detail view, you'll see that you can actually get 15 dB of boost. Not that you'd actually want that much boost, but sometimes what I'll do is boost the band all the way up, cycle through the different options so the tonal differences between the 3 are obvious, settle on the one that I like best, and then tame down the boost to a reasonable level. I do the same thing in the studio with hardware as well. Let's try a high-frequency shelf this time instead of a band. With these you get 4 options: analog, vintage, Baxandal, and resonant. The analog shape is a pretty typical shelf shape with a Q control, which controls more or less the slope of the shelf. Baxandal is named after its creator, Peter Baxandal. It's an old-style gentle slope shelf with no Q control. Resonant is a shelf that uses feedback in its slope, so at higher Q values, the signal at the slope is fed back into itself, creating resonant peaks. If you boost the signal, you get a slight cut before the shelf, and if you cut, you get a slight boost before the shelf. The higher the Q value, the more extreme this is. This is useful because it makes the signal at the boosted frequency stand out a bit more, because the signal just below or above it, depending on whether you use a high or low shelf, is attenuated slightly. And the vintage shape is modeled after Pultec hardware EQs. So let's listen to all 4 of these and boost the high end. Again, what we'll do is boost the gain up quite a bit, decide which tone I like best, and then tame down the gain quite a bit. I think I prefer the back sandal for a nice, gentle high-end lift. Next, let's add a filter. Let's add a high-pass filter. There's 3 options for the filters: flat, resonant, and brick wall. Flat is a non-resonating filter, so you can simply cut frequencies without boosting them. And there's 3 roll-off slopes: 12, 24, and 48 dB. Resonant employs feedback in its slope, so the steeper the slope, the more the signal gets boosted just before the roll-off. So this can be useful to boost the audible bass, but cut out the low rumbly sub-bass that just makes the mix sound too boomy. And brick wall does exactly what it looks and sounds like. It cuts all frequencies steeply above or below the cutoff frequency. This is great if you need to surgically remove bass or high end from a recording. Just so we can hear all 3, I'll pull the cutoff up to about 200 Hz. So what I'm going to do is use the flat high pass to cut everything around 25 Hz just for bass management and excess boominess on subs. I'm going to boost the high end with the back sandal shelf around 5K for a bit of a brightness lift. And I'm going to add a 500 Hz bump to bring out the mid-range a touch. Let's A/B this. So we're hearing just a very subtle tonal difference with a gentle high-end lift. Keep in mind that the frequencies I'm boosting are only like 2 dB and less, so very subtle. On the left here you can choose between an analog or a digital EQ algorithm, which alters some of the filter shapes as well. With analog, you'll notice that this phase slider is not available for each band. This is because analog EQs are what are called minimum phase EQs, meaning that boosting or cutting a band causes phase shifts and phase distortion between bands, resulting in added tone coloring. This can be a good thing or a bad thing. Also, these phase issues can result in more drastic volume or amplitude changes when boosting a band. With digital, you can adjust the phase slider for each band. At 100%, this is minimum phase, like in analog mode. At 0%, this is what's called linear phase. Linear phase compensates for the latency caused by boosting or cutting a band in relationship to the unaffected bands, resulting in less phase distortion and phase shift, and therefore less tone coloration. This also results in less drastic overall amplitude changes when boosting or cutting a band. Linear phase cannot be achieved by analog gear, so all linear phase EQs are digital hardware or digital plugins. Linear phase EQs tend to be used more in mastering because of the lack of tone coloration, but I don't want you to think that analog EQs aren't used for mastering. They are. On many occasions, I've used hardware EQs for mastering to intentionally color the tone of a song. On several occasions, I've mastered mixes that were a bit thin, and I intentionally warmed up the tone with an analog EQ that had tubes and big fat transformers in it. Let's A/B the analog and digital modes. I like the digital mode for this because it's a bit more diffuse sounding. The analog mode sounds good too, but it's a bit too thick and boxy sounding. I'm going to pull down the high pass a bit though, as you can see the slope changes from analog to digital. Let's save this setting as an equalizer preset by clicking here and clicking the add button. I'll call it gentle lift. Also, when you use the digital algorithm, you can turn on this surgical mode, which you'll notice gets rid of all the subtypes for the filter shapes and gives us more focused surgical control over each band. This is great if you're really trying to hone in on a specific problematic frequency range. However, I'm not going to use this here. On the left here, you can process the signal in linked stereo as we are now, separate left and right, and what I find the most useful, mid-side processing. This separates the center from the sides of your mix and allows you to add a different EQ shape to the center and a different EQ shape to the sides. I tend to focus more mid-range and bass to the mid and more high-end shimmer to the sides. So on the mid channel, I'll tame down the high-end boost a bit and pull up the bass in mid-range a bit more. On the sides, I'll pull out the bass and mid-range, but I'll boost the high end. You can also solo the mid and sides channels to hear them individually. Let's save this as a preset as well. I'll call it MS Lift. One last thing, you can reset the entire module and start over by clicking here. Thankfully, we saved that preset, and we can easily recall it at any time. There's one more feature in the equalizer that I'll show in the next video, and that's its matching EQ controls. So I hope you enjoyed this video, and thanks for watching.